project manager of Keio University. I'd like to briefly introduction about our university. So our university is built by Yukichi Fukuzawa. He is a very famous person in Japan because of his face is printed on the 10,000 yen. It's $100 bill in Japan. And headquarters is in Mita, Tokyo, and our campus is Yagami campus in Yokohama. And also, we have the team in Shonan Fujisa campus. So we have the two locations, and that is overall our size of the university. So I'd like to introduce our quantum computing center. We have the two elements, applied research area and basic research activities. And applied research activity based on the IBM Q network activity. IBM, Keio University is the first IBM quantum network hub in Asia Pacific. So we are at the beginning very hard to use a KISS-kit because of the KISS-kit is not stable at the moment in 2018 time frame. So we closely work together with IBM. But actually the hardware is not in our site. So we usually use a quantum computer in Watson, New York. But fortunately, System 1 machine, setting up in Shinkawasaki in Japan. It's 7 minutes from our campus. So we can use these machines through cloud and getting the great support from IBM. And this is open, as I said, 2018 May, and founder is Professor Kohei Ito. He's a founder of this center, and now he is a president of Keio right now. And chair is Professor Yamamoto is the chair of this center, and vice chair is Professor Rodobin van Mita. So those two key professors is leading this team. And at first, when we start this center, there is 5 companies joining. One is IBM, and the other 4 is JSR, Mitsubishi Bank, and Mizuho Bank, and Mitsubishi Chemical. So we work together with them at the beginning. And right now, 4 more companies joining. It's Sumitomo Mitsui Trust Bank, and Sony, and Hitachi, and Toyota Motors. So those 9 companies, and including us, 10 members work together right now. So participating company provides this is a little bit unique, is they provide a researcher on site in our site. So their researcher sit beside us to work together with them. Even if it's a competing company, between the competing companies, they sit together. So that is a good relation between them. And also, they providing the research funding to us for helping this environment. And we provide the outcome to them, like the paper, and also human resource development. So some case, we provide doctor course to them, so some researcher can get the doctor degree during our research. We also collaborate with other universities, like the University of Tokyo, and National Laboratory is like the NICT in Japan. And we also join the community. Community is very important. So to build this ecosystem. So next, this is our structure of team formation. So we have the 5 teams in our center. So the top 4, that is the finance team, chemical team, AI team, and optimization team. This is basic and application activities, and this team led by the Professor Yamamoto in Yagami campus. And basis area system team, this is Rodobin van Mita. He leads this team in Shonan Fujisa campus. So finance area, basically basic and applications area, we developed the theoretical mathematical theory and also constructing the algorithm. So software side we did. And basis area is a relation, how to access quantum computing. And also recently they are developing the like the debugging tool about quantum software. So this is very interesting about it. And our like the center strategies, three we are we think there are 3 key points. So one is promoting open innovation. So open innovation is a very key for us to communicate free discussion and open discussion, open like research. So very key. That is as usual, but this is one of the key activity. And also our activity and public information is open to proactive, such as a symposium. We open the symposium every October to show our activity. And second is this is one of Keio split. This is a half learn and half teach. So this is the teacher and student are not separated, but the one who learn first teach the one who want to learn later. This is a spirit that has existed since the pioneering day of the school, in which half of the faculty and student teach and half continue to learn. That is a very interesting thing. We are using some similar like scenario for the education style, but within the team also we have the like the 6-7 regular weekly meeting in each research area, and everyone can join free. So sometimes finance people join the chemistry team's regular meeting. So this is very like open innovation and open discussion. We can do that. But half learn, half teach means when that researcher come to some meeting, then he learn, and after that he need to make a presentation at a meeting. So this is a trade-off. Anyway, this is one of the our Keio split. Then number 3 is that this is also we are working with companies, so need to control information management well. So we classify the information because of the researcher is various means teachers and faculty researchers and student and also researcher from company. So we need to think about this kind of like the information can open to where and who. So this is what we are doing right now. And the result of our activity is like defined 3 categories. So one is a paper, and one is a participate company, and third is community. So about the paper, so when we started 2018, at the moment, we do not have that much paper at the moment, but we are focused on just try to use the hardware as much as possible. That is what we are doing at the first time. Then second time, after we use a quantum computer well, then we need to define or prove the theoretical kind of things. So that is what we are doing. Then becoming and also supporting our research area becoming expanded to like AI and also cryptography and optimization. Every year we expand our research area. So the good thing is this is a upper right side. We have the many co-authorship papers between the competitors. So this is very unique, but we can achieve that kind of result. So paper is one of the metrics, and also participate company. This is also, we are checking that. So when we started, 5 company joining, and every year a little bit increasing, and right now 9 companies, including IBM, joining. So Keio Computing Center, as a community point of view, we start from 6 members, and right now, 10 members. And after 2020, we have the Quantum Innovation Initiative, that is the University Tokyo start this community, and we are the member of that community. Mainly, this community use IBM computer. So, and also IBM provides the hardware. So one hardware for the, as I said, Shin Kawasaki, that is the actual use, and they provide 2 quantum systems. So second one is like the hardware testing, for hardware testing. So that is very unique and located in University of Tokyo. And the last year, the new like communities established Quantum Technology Innovation Hubs. That is led by government. And before that, Quantum Innovation Initiative is like the member is 14, starting at 14, and now 18 members. And Quantum Innovation Hub, that is a Quantum Technology Innovation Hub. This is starting from 8 hubs from last year, and this year 2 more, and 10 hubs right now, and will be increased next year. That the government leading this one. So in order to make the ecosystem, this is within the Keio. We work together with AI Consortium. That is one of the community in Keio University, and that is very unique. That the Keio student teach the AI and like the AI programming or like machine learning, teach them to the student. So student teach this kind of activity to student. And already total 12,000 students registered AIC lecture for this 3.5 years. So previously, we also worked together with like the high school person in summer school to educate how to use quantum computer. But AIC also started the quantum education recently. So we were working together with them to consolidate some of the education. So this is one of the education area. And the other community, and this one is already, they have the 7 companies supporting that. So it is good for us to expand some ecosystem within the university. And this is I'm get from the government about this chart. This is a hub I told you. And this is a pointer here? No pointer, okay. QII, that is the left, middle of left. That is University Tokyo create that. That is a quantum computer applications. They are looking for that. And we joined that. And there is a top 8 is built last year. And quantum software is led by Osaka University. And Global Industrial Support Center led by AIST. And Quantum Sensing Hub are led by Tokyo Tech University. And headquarters is right in the middle of that. That is the Riken is a headquarters of this hub, total hub. And right side, Quantum Life Science and Quantum Function Creation Center, that is led by OST. And Quantum Material led by NIMS. And Quantum, the left side is a Quantum Security, that is led by NIST. So those 8 is built started from last year, and this year the bottom 2 is added. So one is the International Center for Education and Research Center by OIST, that is Okinawa, very nice place. And the other is the Quantum Solution Center. This is led by the Tohoku University. So there are too many hubs, and we will start to collaborate with them very soon. The reason why there are too many hubs is this is another chart from pick up from the government chart. The upper side is infrastructure near future or near future. It means quantum computer utilizing the supercomputer, right, and also security network utilizing the post-quantum cryptograph and beyond 5G or 6G. And quantum sensing, methodology and sensing, also, yes, utilizing this combined, like the quantum and current technology combined IT infrastructure. And base, like technology is a three big category. One is a computing, that is quantum computing area. That is a quantum technology collaborate with a supercomputer, HPC, AI, big data together. Then we have some innovative computational service we can provide it. The middle of that is communication, and currently quantum security utilizing some current security post-quantum cryptograph and beyond 5G, that kind of things. And we can provide secure and advanced telecommunications. And about sensing area, this is also medical related things is included together. And ultra high precious sensing is we can achieve. This is a future map of the government make it. So that is we are following that. Now we are focused on quantum computing, and probably next year we'd like to think about how to do the hybrid computing, utilizing the supercomputer and HPC. And also, the vice chair of our center, Professor Rod, is the chair of Quantum Information Task Force team in Keio University. So they are middle of one. So communication, he is leading the quantum communication too. So we would like to communicate or collaborate with them, because that is SF Shonan Fujisa campus team is the same team. So that is what we are planning to. But we need to think about how to collaborate with sensing, but still struggling right now. Then this is a sample of research outcome. Okay. So sorry, that is time is almost over. So this is a sample of research outcome, financial, chemical, related. So finance is like finance risk calculation or economic indicator calculation. We have some this kind of output, and chemical is molecule structure, and AI is object identification, image research. So this is the outcome, and probably quick means that this is a finance-related outcome based on this is the papers. So first one, amplitude estimation method, that is a parallelize that require fewer bit and operations. So this is an idea of, the phase estimation is it is hard to implement right now. But in order to parallelize it, and the idea is using the maximum likelihood estimators to complete the result. So that is one thing. And the right top number, this is 4 and 6, this is a co-authorship members. So it means left bottom is 1, 2, 3, 4, 6 member co-author together. So that is very unique, and that is our result of open innovation. And this is an AI-related outcome. So I'd like to finish that. So building ecosystem is like keeping the own strategy is very important, but also need to change as very flexible if need to change somewhere. And also we'd like to expand the ecosystem to within the quantum technology between quantum computation and communication, and also vertically the hybrid with supercomputer. So we are building this ecosystem in next year. And research area, we find some of that. And the net is quantum computer research evolving faster than we expected. So probably the operational mode will be coming sooner than we think. So it's my net message is let's ready for new quantum era. Thank you very much.